So welcome everyone. I'm George. I will chair the session today on ASIC design. First speaker today is Priya Chibuturi. She will talk about the era of agentic engineering. Quick intro is that she's a staff applications engineer for verification software at Synopsys, with 12 years experience in FPGA and ASIC projects across automotive, rail, and vision systems. The stage is yours.
Thank you. Am I audible in the backside? Thank you. So hi, I'm Priya. I'm an applications engineer in Synopsys, and today this is going to be my presentation on the topic, the era of agentic engineering, where I would like to walk you through how we in Synopsys perceive pervasive intelligence and how we are applying agentic engineering to improve the verification efficiency. This is, if I can get this working. Sorry, that's my thought. Yes. Sorry for that. This is a standard legal disclosure. Please do not share or redistribute these slides without Synopsys authorization. Okay. We start with the present-day challenges that we face in the industry from a verification perspective. We see that more than 50% of the respins are due to functional failures, especially in the lower nodes. And this is subsequently also increasing the cost of verification. And we know that in less than a decade time, more than 80% of the chips or the designs are going to be chiplets based, which is going to increase the complexity of the designs. We want, the customers want their designs to come faster into the market by reducing the design cycles, all this while tackling resource issues and the increasing security criticality for verification. Now that said, this is the verification continuum, which is offered by Synopsys. I'll quickly walk you through what you see here. An entire SoC can be verified using the VC simulator, and debugging can be done using the Verdi platform, and static and formal checks can be done with VC Spyglass and VC Formal respectively. The users can also leverage the fastest emulation software in the industry with our emulation platform for an early software bring-up. And apart from this, there are also a wide variety of silicon-proven verification IPs and test suites available. Now, debugging efficiency can be improved using the Verdi unified platform, where users can find and fix bugs across different domains and abstraction levels with the Verdi platform. Now, AI can be used effectively to bring faster and better results using the product called VSO.ai, which I'll be talking about in the rest of my presentation. Okay. In the typical verification flow, let's identify where automation is possible. Considering a simple verification flow, we know that an architectural spec is designed by the architect, and the RTL and verification engineers derive their spec and test plans, and before they go on to developing the RTL and the tests. And after multiple test bench stabilization, after running multiple tests for test bench stabilization, we finally move on to coverage closure. This is the typical cycle. But as you see, all the green circles here are manual processes. And this gives a great opportunity to automate, because we know that, I know you can't see it here, but more than 70% of the verification time spent is typically on debug activities and coverage closure. Now, AI can be applied to wherever there are these manual processes to improve the efficiency. In the early verification phase, where the RTL and test bench are still evolving, the primary goal is test bench stabilization, finding bugs, and to improve the confidence of the RTL. That is where VSO.ai can be applied to improve the stimulus diversity, thereby improving the verification efficiency. Now, after the RTL and test bench have matured, we normally focus on the coverage closure, finding corner case bugs, and reducing the regression time. And VSO.ai has proven to reduce the regression turnaround time by 2 to 7x, thereby accelerating the coverage closure. Now, Gen AI can also be applied to spec automation and design and test bench creation as well. Here, let's look at simple coverage flow and understand how VSO.ai can help improve the coverage closure faster. In a typical coverage flow, the verification engineer manually writes the coverage and stimulus, runs thousands of regressions with unknown return of investment, and then covers the coverage data and analyzes them with very less insights. And then to close the coverage, they have to manually bias the test or write directive tests, which is all very laborious and time-consuming process. Now, applying VSO.ai, which applies the AI to the entire loop, so the VSO.ai can be used to infer coverage, AI can be used to write stimulus for tests that are hard to hit coverage, and by automatically biasing the test, and the regression optimizer can help by running the high return of investment test first, and then AI can also be used to collect the data and analyze it and provide the prescribed insights. So coverage inference engine helps to define coverage from stimulus and RTL. The connectivity engines help by connecting the coverage data with the random variables. And we have a new machine learning based solver which targets the hard to hit coverage areas. And as I already mentioned, the regression optimizer ensures that the high ROI tests are run first. And advanced root cause analysis is used to identify unreachable coverage, and thereby also preserving hardware resource efficiency by not running wasteful tests that are not going to hit unreachable coverage. This is one of the applications of VSO.ai where it can improve the verification efficiency. This application is called change-based verification. Now, we know that regressions are normally run to validate any changes to the RTL through any RTL or test bench revisions. This is to mainly flesh out the bugs, improve confidence, and to still hit the desired coverage closure. Now, VSO.ai, before VSO.ai, the traditional coverage closure methods, which is seed-based, are not aware of any changes or revisions to the RTL. But VSO.ai employs a novel technique that identifies the changes in the RTL or test bench. Now, let us, for example, consider this design, which is this DUT that has 4 blocks, and it takes 27 tests in the regression environment to validate this design. Now, for example, an RTL engineer, he converts an AND block. I don't know why he converted it, but he converted it to an OR block. And he ran the regression, which is based on VSO.ai. And he left to drink his favorite coffee, and he came back. And he would be surprised to find that by the time he came back, his regression run would be finished. Why? Because VSO.ai employs change-based verification, which detects any RTL change and its cone of influence to select the tests for the regression run. So the new regression run would run test 5, 17, and 15, which are affected by the changes in block C. So thereby, it focuses on changes and improves the productivity by running only the tests that are affected by the changes. Our customers have seen tremendous benefit from the VSO.ai. This is actually a paper presented by NVIDIA on during our SNUG, and it is on the topic of reducing manual effort and achieving coverage goals with VSO.ai and VCS with ICO and the unreachability analysis tools. And they were able to achieve 2 to 7x regression turnaround time, reduction in the regression turnaround time, and more than 30% increase in the functional coverage for the same number of runs. And when used with the unreachability analysis tool from VCS, they were able to see 10 to 20% coverage increase for a very less effort. When VSO.ai is used with ICO, they were able to see an additional 17% functional increase. Now, apart from these impressive results, they were also able to prove that VSO.ai can be applied in an earlier stage of the project, which also proves our shift left strategy, which we strongly believe in Synopsys. There are a few other impressive results where our a GPU customer, GPU to mobile, handset, cloud, optical semiconductor, AI chip, they were all able to see an average of 2% reduction in the coverage closure, regression time, and about 5% faster coverage closure. So far, I was able to show you how AI was applied in the verification tool, which is VSO.ai. Now, zooming out a little, Gen AI can also be applied in the entire chip design process. And the applications we see are 3 types: assistive, creative, and agentic. Assistive is where Gen AI acts as an expert guidance on the tools and workflows. The tools that we have are knowledge assistant, workflow assistant, and run assistant. And creative is where Gen AI helps in creating the RTL and tests. We have that in the form of RTL assistant and verification assistant. And agentic is a lot more autonomous, where it executes multi-step complex projects with very less human input. So I'll talk about agentic engineering in my further slides. But first, let me show you an example of how Knowledge Assistant has brought a lot of benefit to our customers. Knowledge Assistant is where the tool is able to provide expert guidance on Knowledge Assistant tool is able to provide expert guidance on the tools that we have in Synopsys plus the workflows. So here we see that Knowledge Assistant has learned from all the collaterals that are available, and any engineer can ask a simple natural language question, and Knowledge Assistant will be able to provide answers from the collaterals that are available to it. And new engineers especially have been able to see 30% faster ramp-up time, which has also helped offload a lot of support time from the more experienced engineers, and 25% faster turnaround time for the support queries, which is great. The other advantage or the other application of AI, Gen AI in the workflow, is the agents. So here we can see these are the available Gen AI assistants or agents that we have currently available. You can see they are available through the workflow for different, which are tightly integrated with the Synopsys tools. Gen RTL can be used for spec to RTL. Lint Advisor can be used for lint fixing in our VC Spyglass static tool. Spec to test plan can be used for spec to test test creation in our VCS tool. GenFV can be used in VC formal, and Spec2 UVM can also be used in VCS. Debug Assistant, which is a conversational debug tool, can be used in Verdi. This is my favorite one. I'll show you that in the next slide. And I've already explained about VSO.ai, which can be used for coverage closure with VCS. And for PPA improvement, we have PPA Advisor in RTL. This is the conversational debug in Verdi. As you can see, the user can ask natural language question, and the Copilot a Copilot will then give you answers in a very understandable, user understandable way. For example, you can ask, if the pointer is here, you can ask, why is the reset signal X here? And it will use the XProp agent, which is part of the Verdi, and it will be able to generate the analysis and answer in a separate window or tab to the side. So this can be a very useful feature for somebody who's trying to learn the tool, who wants to know how to use a particular signal, who wants to understand the driver for a very embedded signal in their design. It has multiple uses, and it's a very powerful time-saving tool, I think. I personally love using this. So from the Gen AI application, our customers have seen a lot of advantage. As you can see, this is the knowledge assistant, where across the board, the customers are able to see 50% faster turnaround time for their queries, and using the AI, and that is for the Gen FV formal tool, they have been seeing very fast results to bring up their designs and verify their designs. I'm sure you would have seen the slide multiple times today or in the past, but this is the L1 to L5 capability, and this is how we see it in Synopsys. We like to call it re-engineering the engineering, and it's a trademarked technology. As you can see, it's called agent engineering, where we believe that from L1 to L5, L5 being the predicted end state, where the human engineers are going to offload a lot of key decisions to the AI agents. And we believe that this is going to bring a lot of advantage to multiple complex problems in the market currently. L1 is where the human engineers are going to take assistance from the AI agents, like the knowledge assistant or the workflow assistant. L2 is where the human engineers can offload simple tasks to AI agent. And L3 is where slightly complex tasks can be performed by multi-agents. And L4 is where the workflow optimization happens through adaptive learning. And L5 is where it is autonomous, and the decision making for a lot of tasks is handled by the AI agents. And it can also handle multitask complex problems. This is how the multi-agent framework works. For example, a human engineer, as we call the super agent, asked, hi, AI, please, because AI etiquette is important, please give me an RTL and test bench that is lint clean, is static and formally checked, is PPA compliant. For example, if it's an Ethernet PHY design, can you please make sure it's protocol compliant as well? And it's a natural human language. So the AI uses this in prompt to plan and orchestrate which AI agents have to be used in the workflow, and it employs the multiple agents to get the task done and gives you a working Ethernet 5 at the end of the day. These are the current agents that we have in the market, and we want to keep adding more so that the verification engineers and design engineers can go on extended holidays. That's it. Thank you.
Thank you, Priya, for your talk. We now have 5 minutes for questions. So I have a question myself.
Yeah.
What methods are there available for integration?
So we do have on-prem and cloud options. I mean, we are constantly working with the customers. We are working very closely with the customers on what suits their requirements. So yeah, we have on-prem and cloud options available.
And all the tools and methodologies you've shown, they are already available to customers? Or?
Yes, they're available.
Okay, cool.
Yeah.
And are they optional or like they are part of the basic tool package?
That we have to talk to the sales and decide on how you want to implement it.
Suggested option.
Yeah. Yeah.
Is the spec hire able to review a spec? Because as a verification engineer, I spend a lot of my time reading the design specs and going like, hang on, you haven't spec'd it properly yet.
Yeah. So that's a good question, because obviously the human engineers are not completely out of the loop. They're still available. So that's a good interception point for the human engineer to be involved and say, you didn't do this well. So bias the decision of the AI agent and say, you can do it better next time.
It'd be quite useful if the AI could actually parse the specs themselves and highlight bits that are missing or where they've not defined something fully.
Yeah.
That kind of issue.
How deep and how well it works, we can I can clarify that with the experts and get back to you. Yeah.
Okay.
Hi.
You first.
Thanks, Loretta. What do you do if the AI generates something that's wrong, or how would I detect errors? If it tells me, for example, my test passed, how do I know it really passed and it didn't just run the wrong test or something?
Yeah, so that's where I would say the human engineer decides on where they want to intercept the flow. And well, again, that's the task of the human engineer, where it's more from decision making to validating the decision. So the human engineer can definitely get involved and validate the decision if they want to have it or not want to have it.
Yeah, it's just did you ask your AI when will it reach L5?
It has already reached
It
L5.
has already.
Yes, it is already in L5. Yeah.
We have time for 1 or 2 further questions from the chat, if there are any.
Yeah, otherwise I've got online questions.
Yeah, online questions.
What are the training sources to be used with VSO AI?
We do have collaterals on our SolveNet, which is our official portal for questions and answers. Yeah. Thank you.
You can take a last one first.
Anyone else in the room?
Okay.
Is VSO AI applicable for subsystem level or full chip verification?
Yes, it is.
Thank you. Thank you. Let's give everyone a round of applause again.